For this video, we are going to standardize the data using Pandas. So in practice, we often encounter different types of variables in the same data set. And so the goal of applying standardization or feature scaling is to make sure that the features are on almost the same scale so that each feature is equally important and make it easier to process by most ML algorithms. So let us have an example. So suppose we have in the data set and we want to show the movie Facebook likes as well as the IMDb score. So we can see here that the movie na Facebook likes are on the scale of thousands. Okay, it can reach up to 33,000, 164,000 even. Okay, so the IMDb score, on the other hand, have range from 0 to 10. Okay, so if you feed this data into the machine learning algorithm, the tendency is that more weights will be given to the movie Facebook likes because the values are so much bigger as compared to the IMDb score. So it is important to scale the values, okay? To scale the values. So one way to do that is to standardize the data and we convert the data into range of 0 to 1, for instance. And this is one way for us to do it. So we have the standardized, new standardized na column equals a specific na value minus the mean of a column. Okay, so each value in a column minus the mean of that specific na column divided by the standard deviation of that column. Okay, so let's say we want to standardize the gross. So let's also print the gross na value. Okay, and this is even worse. Look at the difference between the IMDb score, the gross value, which ranges into million and even billion, and the IMDb score is only 0 to 10. Okay, so let us standardize. Let's see the gross na value. Okay, so what we can do is first compute for the mean of that column. Okay, so we have the mean of the gross is equal to data, or let's work on the clean data. That gross, clean data gross dot mean. Okay, and let's print the mean gross, and it will show us the mean gross. Now we will take the difference. We will take the difference between a value and the mean. So all values in column na gross will be subtracted with the mean. So we have the data, mean data, gross minus mean gross. So that this is our numerator. Okay, so let's print num. So it will show us 5,044 5,044 rows. That this is, of course, our original shape, right? Or the number of rows. And each of the gross na information is being subtracted with the mean gross. Now, we are going to create a new data set. This numerator, the clean data of gross minus the mean, so divided by the standard deviation of the gross na column. Okay, so clean data gross dot std. Okay, so z, and this will provide us values which are much closer to 1. Okay, so And what we can do is also perform standardization on other columns. Like, let's say we want to perform standardization on the IMDb score. So let's say IMDb. And this should be IMDb score. Okay, so clean data, IMDb score minus the mean IMDb. And we have the non-clean data IMDb score. And we have Z. Okay, so we have print, so print Z. So we can as well as the IMDb score are much in similar na scale. So what we can do is to add this as another column to our original na data, or let's say the cleaned na data set. So what we can do is clean data. Then we will create a new na column, and let's name it as standardized or standardized na gross equals Z. Okay, and similarly for IMDb score, we can add clean data, then standardized IMDb score. This means that we will create a new column na st underscore IMDb score equals Z. So enter. And if we view the clean data, so the number of columns is now 30. Okay. So, and we have a new column, standardized na gross and standardized na IMDb score. And as you can see, this is so much better because the scales are so much closer to each other. Okay. And this is what you have to do for other columns.